So we're going to start looking at surface area today. We've covered volume, we've covered vocab. The last thing that we need to cover for 3D geometry is surface area. Volume, when we looked at cubes and rectangular prisms, was pretty straightforward. It was just length times width times height. Surface area is where things get a little bit more complex, and you can see on your foldable that there's like 5 different ways or 5 different shapes, and they're all going to have kind of different ways of finding surface area. So this is going to take us a little bit longer. Surface area is a measurement, or it measures the outside of the shape, so the area of all of the faces combined. So thinking of if I was wrapping a present, surface area would be the amount of wrapping paper it would take to cover that present. If I was building a birdhouse or a toy chest out of wood, it would be the amount of wood or materials that I need to cover the outside of that birdhouse or that toy chest, okay? One of the things we'll get into as we start looking at applying this in word problems is making sure that we really pay attention to when we're calculating surface area if we need all of the sides of the shape or not. So for example, let's say I was making I was measuring the surface area of a glass vase for flowers and it was in the shape of a rectangular prism. Does that glass vase for surface area have all of the sides included? No, because if it did, it would be a glass block, right? For a flower vase, it's not going to have that piece on the top because it's open so that you can put things inside of it. So we'll pay attention to that when we get into the word problems, okay? So today our task or our goal is going to be to find the surface area or learn how to find the surface area of cubes and rectangular prisms. And we're going to start on the first flap in your foldable with cubes. So when we're looking at cubes, it says cubes are unique because all 6 sides are, you can either put equal or the same there. All 6 sides are equal or the same. So that's thinking of like a dice or any other cube where all 6 faces are the same square. Then it says shade the base of the figures above. So I'm going to shade this piece right here and call that my base here. Over here, I'm going to shade this piece and call it my base. Although technically we know in a cube it doesn't really matter which piece I consider the base because they're all the same. They're all the same. Then we've got this box that says SA equals, and that's where we're going to put our formula for the surface area of a cube. Now some of you have found, based on how you folded yours, that box might be a little cut off or it might be in your crease. You can write your formula up top, that's fine too. Okay, so thinking of surface area, it's the area of all of our faces combined. Bless you. If we focus on just one side of that cube, how would I find the area of just one side of a cube? What formula am I using for a square? Don't give me numbers, use the generic.
Length times height?
Yeah, length times height or length times width for a square. Okay, but because this is a cube, I have 6 squares that are all that same area, right? So to find the area of a cube, I'm going to do 6 times the length times the width. Length times width gives me the area of one piece. Multiplying it by 6 gives me the area of all 6 pieces combined. Okay, you can also write out, and this piece you can add to your notes, but you don't have to. You can write out that, or it's the sum of all 6. The sum of all 6 face areas. Meaning you find the area of all 6 of your faces and add them up. Nope. The faster way is to just think of it as length times width on a cube and multiply it by 6. Well, since it's a cube, only one side is labeled because a cube is made of all squares, and because it's a square, all the sides are the same. Yep. Yep. Hannah? Because those are 2 different shapes. We're going to do 2 examples in our notes. So one of them, it's drawn as a 3D shape, and the other one that we're given is drawn as a net, just so you're used to seeing it drawn both ways, but 2 different shapes. Okay, so underneath that on the bottom flap, you'll see that it says use the figures above to find the surface area in the chart. So we're going to start by just rewriting out that formula. 6 times L times W. And then we're going to substitute in what we know. So for shape 1 or number 1, we're looking at the one directly above it that's drawn as a 3D shape. So what are we going to plug in here to solve this? Olivia?
7 times 7 times 6.
Good. So we're going to have the surface area 6 times 7 times 7. And you can either use mental math or a calculator on this one. 7 times 7 is 49. Anyone know 49 times 6? If not, use your calculator. 294. And when I go to put a label on this, we're going to call it centimeters squared. So we used units cubed for volume. We're back to using units squared for surface area because technically surface area is the same thing as area. We're just finding the area of multiple pieces on a 3D shape. Okay, so it's always going to be units squared for surface area. Okay, we go down that first one? All right, shape number 2 then, we've got this net drawn and only one side length is labeled again. So for surface area, we're going to say surface area is 6 times the length times the width. Who can tell me what I'm substituting in for length and width here? What am I going to substitute in here? Vivian?
We're going to do 10 and 10.
Good. So we're going to have 6 times 10 times 10, which hopefully we can do mental math here.
600.
600. Very good. 600, bless you. And again, it was centimeters, so centimeters squared is our label there. Do we have any questions on cubes? That's probably our most basic one. Then they get a little bit more complex. All right, so let's flip in your foldable. We're going to look at rectangular prisms next. And go ahead and put your pencil down because I want to kind of just draw something or sketch something up here to help you start recognizing how this is a little bit different. So when we have a rectangular prism, like this Kleenex box, for example, okay, we can look at a tissue box and see, okay, my top and my bottom, like what it sits on, these are going to be the same shape, right? The bottom and the top are the same. But those are different than other sides. So then I've got these two sides that are this dimension, but they don't match anything else, but there's 2 of them. And then I also have this front side, which matches the back side, but again, they're different than the others. So I kind of have 3 different sets of 2 that are the same shape and size, okay? So when I'm looking at that in this example, I'm going to try to color coordinate here to help you kind of see some things. So for example, I've got the top and the bottom, which are right here. And then we've got the top piece that kind of matches that. The dimensions in this example of the top and the bottom, these pieces are 14 by 5, right? Looking at that. Okay, so that would be, there's 2 of them, top and bottom. Then I've got this side over here. And when I look at this side, the dimensions there are 5 again, but what is the length here? So this one is 5 by 7, okay, and then that one that's on the left-hand side is going to match that. And then I've got one other set, which is this piece out front here. And again, I'm going to have the piece in the back that matches that. But my front, that kind of covered up the bottom, but you get the idea. Okay, the front is going to be 14 by 7, right? So again, a different set of dimensions there. Okay, so for our surface area formula for rectangular prisms, it's going to be a lot more involved. So let's go ahead and fill this in, and then we'll look at some examples. So it says rectangular prisms have its rectangular bases. And actually, all of our faces are rectangular. All right, so our formula for surface area, make sure you get this down right, and then we'll walk through 3 examples here that are going to help you start seeing how this works, okay? So for surface area, we're going to do 2 times the length times the width. Change colors here. Plus 2 times the width times the height. Plus 2 times the length times the height. So essentially, we're going to take each dimension and multiply it by one of the other dimensions. And we'll look at what this looks like again in the example below. So get those down. I'll zoom in a little bit. 2 times the length times the width, plus 2 times the width times the height, plus 2 times the length times the height. Now, I had somebody in the last class ask a really great question about this. The question was, does it matter what I'm calling the length, the width, and the height? Okay, so if I look at the one that's drawn, I have a 7, a 14, and a 5. It does not matter which one is the length, which one is the width, and which one is the height. Because while I might look at these two, my top and bottom being my bases, okay, Owen might be looking at the two sides as the bases, and Nora might be looking at the front and the back as the bases. And on a rectangular prism, we said it doesn't really matter. So it doesn't really matter which is the length, the width, and the height. They're all going to get multiplied together, okay? So let's break this down for this first shape that I've color coordinated. So we're going to have for surface area 2 times, I'm going to call the length and the width 7 and 14 so that it matches up with what I colored red up there. Livia?
Could you also do length times width plus width times height plus length times height and then just multiply all of that by 2?
Yes, so rather than multiplying each piece by 2, you could do the whole length. Yes, what's in parentheses, add them up and then multiply it by 2 at the end. That works too. Okay, so for my red one, again, we said the red one was 7 by 14, right? And then I'm multiplying it by 2 because I've got this one up front, and then I'm going to have one in the back that matches that. Okay, then I'm going to switch over to what I used for green and say 2 times the width times the height. So the green we said was 5 by 7, right? And then going back to what I started with for blue, whoopsies. 2 times 14 by 5. Okay, now look up here and I'm going to show you something before we start calculating here. So what you can see, the first set I did was I multiplied my 7 and 14 together. So sometimes for rectangular prisms, I draw on a line to connect, okay, I did the 7 and the 14 together. Then next I did the 5 and the 7 multiplied by each other. So these two I've multiplied by each other. And then it's fairly easy to see what 2 pieces should be the last 2 that I multiply together.
I don't know why, but I feel like that kind of looks like order of operations.
You are going to follow order of operations to solve it, yes. Okay, so then I can see, well, the 14 and 5 haven't been multiplied together yet, so that's what I did for that last set there. So when you kind of look at each dimension as being multiplied by each of the others, it helps you kind of break that down. Okay, so let's do the math here. 2 times 7 times 14.
7 times 14 is 98.
98 times 2 then is 196. Okay, so then plus 2 times 5 times 7. So 5 times 7 is 35.
70.
So 70 altogether. Plus 14 times 5 times 2. So
70
times 2. 140. Holy cow. Not sure what just happened there. All right, 140. And then our last piece in order of operations is just to add all those together. So 196 plus 70 plus 140.
406.
Perfect. 406, yes? And it was inches. So we're going to call that inches squared. Okay? Make sure you have that down. And then we're going to jump over to examples 2 and 3, and then we're going to stop there for today with our notes. All right, so for number 2, we've got a net now. And again, it doesn't really matter as much what I'm calling my base and my height and all of that, as long as, so I might say this piece is my base. Somebody next to me might call a different piece my base. But I'm just paying attention to the fact that it's 8, 3, and 4, okay? So we're going to say surface area is 2 times, what should my first set of dimensions be?
8 by 4 maybe?
8 by 4. If you were thinking something different, that's totally fine. Okay, so we've done the 8 and the 4 together. So then we're going to say plus 2 times, what do you want to do next?
4 and 3.
4 and 3. Plus 2 times, what's going to be that last set then? 8 and 3 are the last 2 pieces that haven't been multiplied together yet here. So you can see the 8 has been matched with the 4 and the 3, and then the 3 and the 4 were matched together as well. Okay? And then we're just going to multiply. So 2 times 8 times 4. 8 times 4 is 32, times 2 is?
64.
Good. Plus 4 times 3 is 12, times 2 is 24. Plus 8 times 3 is 24, times 2? 48. And then we just need to add all of those together. I think somebody just whispered it. 136. 136, and again, it's going to be meters squared on this one because the original measurement, the label was meters. Go ahead and get that copied down. Do we have questions on that one? Are you starting to see how those pieces kind of go together and how we figure out what to plug into the formula? All right, let's look at this last one then. It says, number 3, a box of laundry detergent measures 11 inches by 8 inches by 9 inches. How many square inches of cardboard is needed to create the laundry detergent box? So if it helps, you are welcome to sketch that box. Some people have a hard time sketching 3D shapes. So I'll tell you this now, and then I'll try to remember on your summative too. A lot of times on like your summative or on a worksheet, when you have a word problem like this, the shape might not be drawn for you. If it would help for you to have it drawn, and you know that when you draw it, it kind of ends up looking like this, which is not helpful, I am happy to sketch them out for you. Okay, so if you need me to draw a rectangular prism or whatever it is on a test or on a worksheet for you, I'm happy to do that for you if you're having trouble drawing it yourself. Okay, all right, so I'm going to label this as 11, 8, and 9. So how many square inches of cardboard is needed to create that box? So the cardboard to create a box of laundry detergent, that's surface area again, right? So all we're doing is solving for surface area here. Who wants to tell me the first set that you're going to multiply? Leo.
11 times 8.
Okay, so we're going to say 2 times 11 times 8. Plus, who wants the next set? Jonah.
9 times 8.
Good, so 2 times 9 times 8. And what are we missing there? 11 times 9. 2 times 11 times 9. Good. We'll multiply and then add at the end. So 2 times 11 times 8. 11 and 8 is 88 times 2. 176.
4.
What do you mean 4?
4.
Go again.
Doesn't matter. We've got it. 176. Next one. 9 times 8 is 72 times 2.
144.
144. That one's got a 4 in it. And then 2 times 11 times 9.
188.
You sure?
No. 198.
198. Go ahead and add those up. $518.
534. 58. I'm probably wrong.
I think 58. Nope, I think 518 is right. 518 square inches. So that tells us that we need 518 square inches of cardboard for that one.
That's not a lot of cardboard.
That is a lot of cardboard, so that's probably not super accurate. Well, it seems like a lot, but it's square inches, so